Thank you for joining this lesson. We're going to study quantity of heat. State one factor that affects the freezing point of distilled water. So some of the factors affecting freezing point of distilled water can be intermolecular forces. Another factor can be the pressure. Part B. The figure below illustrates an experiment in which electrical energy is used to determine specific latent heat of fusion of ice. Then we are told we can see a beaker, we can see water from melted ice, a funnel, we can see ice which is at 0 degrees Celsius. Then we can see a circuit diagram here. Complete the circuit to show connection of essential components. Essential circuit components which are essential in this one. So in this experiment, something we need is a voltmeter because voltage has to be measured. So voltmeter should be across these cells. Remember, voltmeters are never connected in series because when in series they can offer a very large resistance and the flow of current won't be smooth. Then we will have an ammeter so that we record the current. An ammeter is needed. This is a switch. So that is the essential components in the circuit which were missing out. So the diagram should be that way. Let's check the next question. Complete the circuit to show that one is done. In the above experiment, the following readings were obtained when heater was switched on for 10 minutes. Very important. For 10 minutes. Voltage 8, current 2.25, temperature rise 10. The temperature rise is 10. At the end of the experiment, 400 grams of water at 0 degrees Celsius was collected in the beaker. Determine the latent heat of fusion of ice. So what we should understand from this experiment is that because ice is already at 0 degrees Celsius, ready to just melt, then it is assumed that all the heat supplied by the heater is going to be absorbed by the ice, and the ice is going to melt due to that heating. Therefore, we are going to say one of the assumptions assumed in this is that no heat loss to the surrounding. No heat loss to the surrounding. No heat loss to the surrounding. Let me now calculate the above. We are saying heat supplied by heater. Heat supplied by heater. Heat from the electrical heater is given by power times time, the heat energy. So power times time, and the power itself is given by voltage times current. So voltage times current times time will give us the electrical energy supplied. So this is going to be voltage 8, current 2.25, time 10 minutes multiplied by 60 to convert to SI units of time, which is the second. 8 times 2.25 multiplied by 10 by 60. This is going to give us 10,800 joules of energy. 800 joules of energy. So now we can again say, because 400 grams were collected, the heat absorbed by ice is going to be mass of ice times the latent heat of fusion, because it is happening at constant temperature. Therefore, we're going to say this heat absorbed by ice, which is the mass of ice, 400. We make it as a unit by dividing by 1000, multiplied by latent heat of fusion, which is unknown, is going to give us the same heat which was supplied by heater. Remember, the assumption is that no heat losses to the surrounding. No heat losses to the surrounding. Therefore, to remain with latent heat of fusion, we need to divide 10,000 by 0.4. 10,800 by 0.4. So this is going to give us 27,000 joules per kilogram. Joules per kilogram. Thank you for following. Subscribe and share.